Hello all! So, the purpose of this is I just want to take a moment and go through the argument that the angle addition formula for cosine is what it should be by using right triangle trigonometry. Uh, Things went pretty sideways during the morning lecture when I tried to do this because of stupid technical issues. It kept obliterating whatever argument I was making by just not letting me show it. So let me draw a picture of how the proof will go. So, yes, very good. Here's a happy right triangle. Let's label it so that this angle has measure A, and this length is 1. Now you can look at that and see that that means that this side length has to be the cosine of A, this side length has to be the sine of A. I will extend from this a right angle, and extend from here an angle of length B. So, at this point, I do see an angle of measure A plus B right here. So if I can build a right triangle out of this, then I can use that right triangle to study the trig functions at A plus B. And how will I do that? I'll extend this yellow line even further. Now I see a happy right triangle. Let's label some of the points. So let's call that point O, because it's like the center, it's like the origin. And now I'll just go alphabetically. Let's go alphabetically starting at P, because I seem to already have little a's. P, Q. Let's call this point R, and this point S. So by right triangle trig, I know that the cosine of A plus B should be equal to the length of OP. And let's actually denote length in a slightly different way. Length of OP divided by the length of OQ. So if I can figure out what the side length OP is and what the side length OQ is, then in some sense I'll be done. Maybe there will be some simplifying to do. So basically the philosophy is, here's a triangle that should have the information that we need. Let's take that triangle and let's just run with it. And here by running with it, I just mean let's try to find any facts we can out about this triangle. And eventually, I guess, we're aiming to know what the side length OQ is. Because we already know how long the side length OP is. The side length OP is cosine of A. So let's do this. Well, I guess we can start by just doing some right triangle trigonometry using the yellow right triangle. Let's use this right triangle and see what we can do. So let's just walk with it. So I know what the tangent of B will be. The tangent is opposite over adjacent. So that will be the length of SR divided by the length of OR. But I know what the length of OR is. It's 1. Nice. So that means that the length of SR is exactly tangent of B. So that's nice. That gives me one of the sides in that uppermost triangle, which is mysterious right now. Let's try to compute some angles in it. So let's compute anything we can. So do what you do. I'll maybe start with this. So I know that that yellow triangle is a right triangle. It has one angle of length of measure B, so this angle will be pi minus B. If you happen to be of the mindset that you would rather use degrees, then I guess you would want 180 degrees minus B, but I'll use radians. Similarly, this angle down here will be pi, oh, that should be a pi over 2. This right angle will be pi over 2 minus a. So the next thing to see is this whole this whole angle totals pi. So if this little angle there is length x, then I know that pi over 2 minus b plus x will have to be equal to pi. I can solve that for x. This angle right here is pi over 2 plus b. I guess I can now study the big triangle OQP. I know this angle is b plus a. I know that this is a right angle, so this top angle will be that top angle will be pi over 2 minus b minus a. And finally, this angle down here, well, I could use it either by just using that red triangle, using that those angles have to add up to pi, or I could say, well, this 180-degree angle is an angle of pi. So that's pi over 2 minus a plus another pi over 2. So far here is pi minus a. Looks like I just need a more radians. So now that I have all those side lengths measured, let's zoom in on the triangle SQR. S. This one is R. Let's make it R. Q. So I know that this angle is equal to that side length is the tangent of B. This angle is pi over 2 minus a minus b. I know that this angle is, reminding myself by viewing up, pi over 2 plus b. Pi over 2 plus b. I know that this angle is a. Aha! So this is an angle side angle kind of situation. Angle side angle. I know an angle, I know a side, I know an angle. So I can use the law of cosines. By the law of cosines, SQ divided by the sine of the angle opposite, sine of A, is equal to this side length, which I know that side length is the tangent of B, divided by the sine of pi over 2 minus a plus b. That is this angle. So, solving for SQ, it looks like SQ is equal to the tangent of B times the sine of A divided by this. But I should simplify that. The sine of pi over 2 minus a plus b, that's the same thing as the cosine of a plus b. Cool. So, let's go back to this top triangle. That means that I've just discovered this side length. That side length is now known. But if I know this side length, and I know this side length, then I know that whole hypotenuse of the big triangle. Oh, so I guess I haven't computed the length OS. Let's do that. So, the cosine of B. No, I shouldn't write it there. This is really bad board form. The length from O to S. So I'll use that yellow triangle again. That yellow triangle will tell me that the cosine of B is equal to adjacent over hypotenuse is equal to 1 over OS, because that is the hypotenuse of the yellow triangle. So that means OS is the secant of B, right? You would multiply the OS to the other side, divide the cosine, 1 over cosine is secant. Nice. So now, I know the whole length from O to Q. That is the same thing as the length from O to R, plus the length from O to S, the length from O to S plus the length from S to Q is the length from O to Q. So the length from O to Q is OS plus SQ. And I know what those are. OS, I literally just computed, it is the secant of B. The length of SQ appears right here. It is tangent of B times the sine of A divided by the cosine of A plus B. Now, I can do what I said I would do to begin with. I can look at that big triangle, big right triangle, and use that to compute the cosine of A plus B. The cosine of A plus B will be equal to adjacent, OP, divided by OQ. Now just writing down what those are. The length from O to P is cosine of A. Divided by the length from O to Q is, well, it's written right above. Maybe I'll write that secant as 1 over cosine of B plus, I'll simplify the other bit too. Tangent is sine B over cosine B times sine U divided by the cosine of A plus B. Nice. So let's just simplify that. That gives me that the cosine of A plus B is equal to, well, I'll leave that cosine of A on top. And it looks like that denominator needs a whole ton of simplifying. 1 over cosine B plus, let's simplify that other fraction. So that other fraction is sine A sine B divided by cosine B times cosine of A plus B. So in the denominator of that fraction, I see two fractions added together. I'll need to get a common denominator between those two things. Cosine of A divided by, so I'll multiply and divide this piece by, I guess, cosine of A plus B, giving me cosine of A plus B plus sine A sine B divided by cosine B cosine A plus B. Now in the denominator, I see a fraction. What does it mean to divide by a fraction? It means you multiply by the conjugate. Equals cosine A times cosine B cosine A plus B all over cosine A plus B plus sine A sine B. So there's one interesting thing that we see right here. I can divide both sides by cosine of A plus B, leaving me with a 1 on the left-hand side. 1 equals cosine A cosine B divided by cosine A plus B plus sine A sine B. And at a glance, that might make you upset, because I wanted to know what cosine of A plus B is, and I just got rid of cosine of A plus B, but that wasn't the only cosine of A plus B. I still have one down here. So I can still try to solve this for the cosine of A plus B. So I guess I should multiply that denominator over to the other side, clear the denominator, cross-multiply, whatever you prefer, which will give me cosine of A plus B plus sine A sine B equals cosine A cosine B. Subtract this over to the other side. Cosine of A plus B is cosine A cosine B minus sine A sine B. Wonderful. So I hope you enjoyed this. There's another proof of this posted as an extra credit for you guys to go through, which is very different from this. This was using the philosophy of triangles to study trigonometry. We can also use circles. So I'll go ahead and get this posted. I hope you enjoy it.